Alright, continuing on to question 11. Claudia carried out an experiment to find out how the size of bread affects the rate of digestion. So just based on what we already know, this has to be a change variable, and this is your measured variable. She put some bread into each setup as shown below. Okay, based on the experiment of his result, what can Claudia conclude? I believe this should be a she. Change this to a she. Okay. So what is the change variable here is the size. Can you see? So this is the change variable. So this is actually smaller, and this is actually bigger. Alright? So remember, when we talk about smaller and bigger, there is actually a representation or proxy. So basically what it represents is the amount of exposed surface area to the digestive juices. That is what is the change variable. It's not just so simple as smaller and bigger, but rather the amount of changed variable. Okay? Now, then after that, that means this is actually the size, right? The size is actually increasing. Okay, and this over here would be rate of digestion, because you are seeing how much of the bread is being left over. So the faster the rate of digestion, the lesser of the bread will be left over. So this is actually decreasing. Okay? So based on this result experiment, what can you conclude? So probably what Claudia can conclude is that, okay, as the size decreases, alright, rate of digestion increases. Now, why do I phrase it in such a way? Because it makes more sense. Technically, you cannot, in the experiment, you did not make the bread bigger, but rather you made the bread smaller. It's just the way they arranged it, right? You did not add more bread. You did not make the bread bigger, but you made it smaller. So therefore, as the surface area of the bread increases, the rate of digestion increases. Okay? As the exposed surface area of the bread to the digestive juice increases, the rate of digestion increases. Okay? This part and this part. Okay, so one more time. The size of the bread actually represents the amount of exposed surface area to the digestive juice. Okay, moving on, question 12. Mr. Moto put tea by transferring hot tea from one container to another at a certain distance for 5 times and created a cup of put tea. Just in case you didn't know, put tea in the local Singapore culture is known as teh tarik. Okay, tarik is to pull. Alright? Now, his son Danish conducted an experiment to find out the distance between the containers and how it affects the final temperature of the put tea. So, remembering what we learned, cause and effect, this is actually your CV and this will be your MV, measured variable. Now, just to sidetrack a little bit, teh tarik is actually very popular in Singapore. So the reason why you even do teh tarik is not only because it's an art, but it's also for very practical reasons. The first thing is that it decreases the temperature of your tea to lower it, therefore making it more drinkable. Number two is to froth up the tea. Somehow when you get this frothiness, people like it a little bit more. Alright, it's just like your latte with the froth, the milk froth or the milk foam on top. Alright, there you have it. Okay, so if you were to look at it, once again, draw your arrows. Okay, I'm very adamant about this because I want you to do it. So this is distance increasing. And as my distance increases, I realize that the final temperature will actually decrease. Right? But wait, does this distance, does it mean anything? Okay, this increase in distance actually translates, it's a proxy once again, it's actually talking about increasing exposed surface area to the surrounding. Right? Because when you think about it, as the distance of the tea increases, it also means that more part of the tea. So if you have 2 cups, okay, imagine there's 1 cup here, and then you pour, right, another cup. And then you have another scenario whereby you have another cup and you increase the distance of this cup. Right? So because of the increment, you would see that there is actually more exposed area. So more exposed area means that heat can be lost from your tea to the surrounding at a faster rate, lowering the temperature. Alright? So based on the result of his experiment, what can Danish conclude? So he can conclude that as the distance between the containers increases, the rate, the final temperature of the put tea decreases. So if they ask you to explain why is that so, then you say because as the distance increases, the amount of exposed surface area to the air also increases. Hence, heat can be lost from the put tea to the surrounding at a higher rate. Okay? Alright? Next. Okay, question 13. Okay. Andy conducted the experiment shown below to find out how plants affect the temperature of its surroundings. So basically, you can do, this must be change variable, and this must be your measured variable. So in the experiment, you will see that one has plant and one the plant is absent. Okay? He poured an equal amount of water into both pots and placed both setup under the sun in the field. Any excess water in the setup will flow through the opening, okay, to the beakers. NT recorded the temperatures inside the containers at the start and at the end of the experiment. The results are shown below. Okay? Now, based on the result in the graph, what can Henry conclude about the experiment? So what is the change variable, which I have pointed out to you already? Presence of plants. Right, and the measured variable will be the temperature of the air in the containers. So what can he conclude looking at the trend? So basically, if you look at it, with and without. So if I were you, I'll write it down. So A has a plant, okay, B, no plant. So with the plant, you know that it is at a lower temperature, okay, higher, when you compare the two. So in short, you would know that with a plant, your temperature actually lost heat faster, okay? So he can conclude that the presence of plants decreases the temperature of air inside the container. Right? Because with, you actually got a lower temperature as compared to don't have. So this tells you that what did the plant do? It increases the temperature. Now the next part that I'm going to talk about is very important. Something that is actually very, very prevalent. Fair test. So if you remember, okay, fair test has got to do with your one change variable. That's about it, making it fair. However, before I start on this, I want to explain something to you that is not so straightforward that you will observe. So what students like to do is that whenever they ask, oh, why is this a fair test? Then they will always go, oh, you know, it's such that there is only one change variable, so that is a fair test. No. You need to look at the question. If they specifically say something like, okay, why is it that the two containers used must be exactly the same? So you ask yourself, how would using the same container affect the outcome of the experiment? So for example, if it's an experiment about evaporation and you want to know how does temperature of the surrounding affect rate of evaporation, your container, if you use a different size one or different type, might affect the exposed surface area of the water in the container to the surrounding. So it becomes two variables. So you have to explicitly pinpoint what is it that the container will affect. So you will say this is to ensure that the exposed surface area of the water in the container is exactly the same. Hence ensuring that it is a fair test and the results are due to the change variable only, which is the temperature. So it's not good enough to just say, to ensure that there's only one change variable. You must tell me what could possibly change, or what additional change variable you could have introduced if you did not ensure that the size of the container is the same. Based on the experiment, I will demonstrate to you. I'm just teaching forward. Okay? So, yes, in the fair test, there is only one change variable, okay, which is what? Which is changed, okay? is the experiment affected? Oh, sorry. Okay, so this is actually linked. Okay, so we take a look at this. Okay, so I believe that this one, the experiment seems to be missing. Okay, so in this case, actually what they wanted to say is that they wanted to see if the amount of light affects photosynthesis. Okay, so what happened is that okay, wait, we will take a look at this question again in a while.